mathematics oriented. Okay, so our chapter is alternating current, right? So, so far in grade 10, what you have been studying all was direct current. So let's first get a hangover of what is alternating current and what is direct current. So chapter name is alternating current. Now, many people will use the word AC current. AC itself includes the word current. So using the word alternating current actually doesn't make any, AC current does not make any perfect sense of it. Alternating current or alternating voltage, right? So let's first understand what is alternating current from our understanding perspective. Okay, so far what you have, because if your concept is clear, you will understand the things easily. Let's say I have a signal, I have a current signal, or let's say I have something called a voltage signal. Now, for example, you are using a mobile phone. Your mobile phone is charged with a voltage of 5.1 volt. Now, this 5.1 volt is a steady voltage. Okay, if you take out your mobile charger, so definitely two wires will come out. The potential between the two wires is always 5.1 volt. Have you understood? And say your mobile has got a charging capacity of 3 amperes, means when you connect, the maximum current that will be traveling is 3 amperes, and this is steady, which means let's say this be an axis on which this is called time, and let us say for the sake of current we'll study with current. Okay, this is current. Now when you say a 3 ampere current, when I say a 3 ampere current, this is what you have been studying so far in grade 10 and all. It's a steady current, means this is 3 ampere. With the change in time, the current is not changing its polarity. Its polarity means it is not coming. So if this is the plus I axis, then this is the minus I axis. Have you understood this part? Okay. Say in some of my project work, I have got a current. I need a current which is a negative 2 ampere current, right? Negative 2 ampere. So a negative 2 ampere is somewhere here. Say, let's say a negative 2 ampere is here, and this is negative 2 ampere. Now this is also a direct current. This is also a direct current, because this current is not changing its polarity. Polarity means the current is not dipping from top to bottom. Is this understood? Right. Now, let's say I have a signal now, children. I have a signal in which I'm mutating this diagram itself. So don't get confused. I have a signal in which my current is going in this manner. Now, what is your take on this third current? This is also direct current. This is a variable direct current, because the current has not crossed over the zero mark. This is where children get confused. They think that this is alternating current. This is not alternating current. This is a direct current, but a variable current. Shall I call this as a steady current? No, I will not call this as a steady current. I will be calling this as a direct current, but the current is varying, because what is varying, my child? The magnitude of the current is varying with respect to time. Are you able to understand this concept or not? The magnitude of the current is changing. Whereas if you see the first two examples, the magnitude of the current being constant, one being a positive magnitude, one being a negative magnitude, but we will say both the currents are direct current, and the third one is a variable direct current. Is this understood? Okay. Let's see a fourth signal now. My fourth signal is something like this. Now this is alternating current. This is alternating current, because with respect to time, my magnitude is showing a positive value also, as well as my polarity is changing in this case. Have you understood? My polarity is changing. So this will be known as a, what should I call this as? I'll call this as a variable alternating current. Variable alternating current, because every time there is, this signals are such that after this time you got this much, then it's not following any pattern. Have you got it? It's not following any pattern. Now, when you go to grade 11, okay, and you think about simple harmonic motion, and you think about your chapter called simple harmonic motion, then you must have studied that a simple harmonic motion is a periodic motion. Yes or no? And a simple harmonic motion can be represented by what, beta? A simple harmonic motion is represented as y equal to y naught sine omega t. Let's come from very basic. Y equal to y naught sine omega t. Instead of writing y, I will write y at a time t is equal to y naught sine omega t. Now what is this? This is, let's see from mathematics perspective. This is a trigonometric function, sinusoidal function. So if this is a sinusoidal function, this function's maximum value should be +1, minimum value should be -1. Do we agree or not? Okay. So let us say that this is a +1 and this is a -1, right? Here, let us not consider about current. Let's say that this is a spring. This is a spring doll which is there on the dashboard of your car. So the spring is right here, and you compress and release it. So the spring will be going up, going down, going up, going down in this manner. Yes or no? The spring will go up and down. So when the spring starts going up and down, see how, just try to understand. Suppose there is suppose this is a pen, right? And this pen is going up and going down. This is its steady state or mean position. The pen goes up, the pen goes down. What happened? Hello? Yes. ठीक है चलो. Okay. Hey, hang on then 1 minute. These children.
Recording in progress.
I'm really sorry, sir.
The only thing is that if you attend the class, attend on time. It is not that. See, when you halfway the whole the concentration goes away. But what is sorry for you in 1 minute is not okay with me. My concentration I lose. Anyways, so as I was saying, suppose let's understand that this is a piece of pen. This is the, but we need to understand how this thing comes up. This pen is right now at a mean position, right? And the pen is attached with a spring. So the pen can go up, the pen can go down. The pen will go up and go down, right? At that time, as it is going up, try to understand what I'm saying. As it is going up and going down, I asked Zoe to keep one kitchen tissue roll out here in this manner, right? And she keeps on pulling the tissue roll with the nib of the pen touching the tissue roll. You will actually see that a wave front has been created on the tissue roll. Are you able to understand this? So that's, what does this simple harmonic motion tell me in grade 10? It tells me what is the displacement. And I say that, say suppose my vibration is happening to a simple harmonic motion. This is the equation of a simple harmonic motion. It will tell you what is the displacement of y at a time t. So this is, say this is the time t. What is the displacement of y at a particular time t? So my pen is moving up and down. So along the time, if you open the tissue paper roll in this manner, it is going to plot, and the plot will be sinusoidal. Does it make sense? Okay. So I say that, let's say this is time, and we are taking one time period. One time period. What is time period? Time period is capital T. Capital T is the T in which one cycle will be completed. One cycle means one pull to and one pull fro. Means if it goes up, it will come down and again come back to its mean position. So since this is a sinusoidal function, this is a, say, a pi by 2, which is 90 degree. Then I have a pi, which is 180. I have a 3 pi by 2, which is 270 degree. And I have a 2 pi, right? The time taken till here, the time taken till here, this time will be known as, now this is the radians, this time is known as, let's say, let's put my time here. So this much time is known as the time period. This time period is say t. Have you understood? And let's say this time period t is 1 second. Have you understood? Let's say 1 second to complete one cycle. So how do we see our cycle of a sinusoidal function? Our sinusoidal function will take like this and then again go like this. So in this 1 second, bacha, I did what? I did one cycle. So what is the frequency? My frequency will be set to be 1 cycle per second. These are basics of simple harmonic motion or periodic sinusoidal motion that I am trying to teach you. Then we will go to alternating current. Till here, have you understood? This is one complete cycle. One complete cycle takes a time t, right? And that t is known as the time period. And if you do one cycle, let's say that time period is 1 second. In that case, we will say that you have actually had a frequency of 1 cycle per second. And this will be known as one wavelength. One wavelength is distance traveled by the wave over one cycle. This is called one wavelength. Is this clear? When you look at omega in these type of equation, omega will be known as my angular frequency. Omega will be known as my angular frequency. Omega is angular frequency. And the value of omega will be, these are grade 12, 10, 11, 2 pi f. Where f is my linear frequency, that is 1 cycle per second. And f is also known as frequency is 1 upon time period, beta. So omega can also be written as 2 pi by t. ये सब लिखते जाइए, आपको जरूरत पड़ेगा. Frequency is measured in hertz, time period is in seconds. So frequency is also measured in CPS, 1 CPS, or we will say this is 1 hertz. 1 hertz. Okay, another question. Imagine that this is a function, some function. In one complete time period, there was a positive cycle, there was a negative cycle. Right? So if we see it in simple harmonic motion, that spring went up once and again compressed and went down once. When you are sitting on a cushion, or you are actually, so if this was a diminishing function, like when you are seated in a car and the car is going over rumble strip, so it will be, if your shock absorbers are good, slowly this should become linear. You should not vibrate along with the seat. Concept समझ में आ रहा है तो ठीक है? Okay, this y naught is known as the peak value, which is also known as the amplitude, maximum displacement. That means in our case, y equal to y naught sine omega t, this will be your y naught, and this function is representing y at any time t is given by y naught sine omega t. This is y naught, this is negative y naught, positive y naught, negative y naught. Clear? Had this been a cost function, generally we show it by sine omega t. Even a cost function can also be there. If it is a cost function, it will be coming from here, from a negative pi by 2 it will be coming. It will be coming from a negative pi by 2. So it will come to pi by 2. Then it will take a peak value at pi. Then make a 0 here. This is the cost function. This will be your function for y at any time t is y naught cos omega t. This much I think from trigonometry you are fine with. So keep an eye on the equation omega is equal to 2 pi f and f is equal to 1 upon t, y is y sine omega t. Clear? Right. So we're now in a position now to get inside our alternating current. Okay. So in the last chapter, when you studied about mutual induction, at that time when you tried to find out the value of the alternating current or the alternating EMF, or say the alternating current, then we got E is equal to E naught sine omega t. Do you remember? E is equal to E naught sine omega t. which tells us that an alternating current will always have, sorry, let's say an alternating EMF. Okay, so let's say an alternating EMF. We usually show it by this sign. This is given by E at any time t is given as E naught sine omega t. This is alternating. This is called a sinusoidal alternating voltage. Get the concept clear? Okay, what I'm trying to say, this voltage will be something which will follow this curve, right? You can also have a voltage alternating which is following this particular curve. This is an alternating voltage, not sinusoidal alternating voltage. This is sinusoidal alternating voltage. And we saw that BA cos, you remember, flux was minus L d L d phi by, so what is EMF? EMF is always given by minus d phi by dt, and phi was what? BA cos theta. So instead of when theta we made as omega t, we got E equal to E naught sine omega t. So this much is known to you, right? So let us understand. Now, going further with this much topic, let's understand the concept of first alternating current and alternating EMF. Now, this is alternating EMF, means if I have an alternating source, if you have an alternating source like this, right, and you connect this alternating source, say over a small resistor R, say this is my resistor R, right, and the alternating source is giving me what? E at time t given by E naught sine omega t. I would like to find out how much current is actually flowing in the circuit. I have not put any arrow now because I am not dealing with direct current or unidirectional current. My current is now alternating. So I would say I is equal to V by I, Ohm's law. You put V upon I is equal to R. So I should be equal to what, beta? I should be equal to V upon R. Right? But we will not write as V upon R because now we are in alternating current. So we'll write E upon R. E means E at t. See, in book they might sometimes write E equal to E naught sine omega t. Why I am writing E as t? Means this is a function of time, right? So what is this value equal to? This value is equal to E naught sine omega t divided by R, and this is your instantaneous current, which is given by E naught by R is taken as I naught sine omega t. So this is the birth. We will study this once again. This is the birth of current and voltage. Have you understood? So the current is also a sinusoidal signal. That means our understanding of sinusoidal signals have to be absolutely perfect in order to go ahead with this chapter. Got it? Now, one more thing. E naught is always a constant. That is the peak value. And R, R is constant. So E naught by R is a constant, which is known as current. So if you look at say if I look at a what do you call a graph out here of a sinusoidal voltage, okay, sinusoidal voltage. So I have say a pi by 2 out here. I have a pi, I have a 3 pi by 2, and I have a 2 pi out here, and this is showing the time scale t. Obviously there will be peak values. Now the peak values of a sine function are +1 and -1. But this has got a coefficient with it. Like just children see this. Say for example, sine omega t. Sine omega t's peak value will be what? +1, -1. But now you have what? You have E naught sine omega t. So the peak value now will be, this will be negative E naught and this will be positive E naught. Is this understood? With the +1 you will multiply that. So I am writing this as E naught plus, E naught minus. Agreed? And let's have a quick look at the voltage signal. So my voltage signal goes in this manner. I get a peak out here. I'll get the peak out here, and then I get a trough out here. Fine. We will revisit these things again. I'm just trying to bring your attention to so that you get a fair bit of idea about what this thing is all about, right? So let's say now, let's try to plot the current signal. So if you look at the voltage signal is sine omega t. The current signal is also sine omega t. Such signals are said to be in the same phase. Same phase means they are all going up and down together. But what should be the maximum value of the current? I naught. Now, should the I naught have a more sharper spike than the voltage curve, or should it have a less spike? That you tell me. That you can answer from this. You understood what I'm trying to say? Why it will be less? Yeah, it's divided by. I naught's value is E naught divided by R. So what we will create now, I naught will be somewhere here. If you try to see on the same thing, and now I naught signal will be going in this manner. Are you getting a fair bit of idea? So this will be my I naught plus, and this will be I naught minus. If you have understood this much, also more than enough for me. And they are going in the same phase. Do you understand? Same phase means both will have their peak value at the same time. Both will have zeros at the same time. Both will be, having their half value, 1/3 value, 3/4 value, 5/8 value. Everything will be same. Just the difference is that whenever I get half pocket money, you will also get half pocket money. But your initial allowance is less than me. My maximum pocket money is 10 rupees. Yours is 8 rupees. So when I get half, I get 5, you get 4. Have you understood? When I get 1/10, I get 1/10 of a rupee, you get 1/8 of a rupee. But the pattern will be same. But later we will see this pattern will be same only when the circuit is a pure resistive circuit. Only when you have a resistance in the circuit and no other thing. Sir, what are those no other things? Well, let's go back to grade 10. Grade 10 used to study about 3 things called VIR, voltage, current, and resistance. Do you agree? Here we will be studying about alternating voltage, E at T. We will be studying about alternating current, I at T. And we will be studying about a resistor. We will be studying about a capacitor. We will be studying about an inductor. 3 different type of loads. Pure R circuit, pure C circuit, pure L circuit, and then we will see a pure LCR circuit. In daily life, every electrical appliance is a combination of this. You can just ask me, sir, how do you prove that? Okay, I have a bulb. Don't you think the bulb has got a resistance? Yes. So it's a resistive circuit. The bulb's filament is like a coil. So the bulb is also having little bit of inductance. But for the bulb, the inductance is less. But when I'm running a fan, it's all coils. Inductors are coils. This has so many coils inside it. So it's a more inductive device. A microwave oven is a more inductive device. There will be capacitance also. So every electrical device is a combination of all these things, which is known as a RLC or LCR circuit. Whereas when you were studying DC circuits, you were seeing resistance. You saw capacitance also. But here we will be seeing RLC. So we'll first see a pure resistive, pure capacitive, and pure inductive. What you saw in pure resistive is that both go in the same phase. But when it will be a pure resistive, an inductive or a capacitive circuit, you will see in one case current will be leading, in one case current will be lagging by a pi by 2. Means the voltage will be running ahead of you, the current will be either running behind or running ahead. Baseline, okay? Then we will also solve some problems. But that is not important. What is important right now for us is, we go back to our, this chapter is more of interest to me. So I'll not try to go overboard. So we have this plug point and it writes 240 volt AC, and this is written as 50 hertz, which means as long as we are in India, we expect our voltage to be 240 volts AC, which is from 220 to 240, and 50 hertz. And if you are in US, the same thing is 110 volt AC, 60 hertz. Means in their case, the frequency is, we saw 1 cycle per second. It is so fast that it is 50 cycles per second. Every cycle, the polarity is changing how many times? 2 times. So in India, Over 1 second, how many times the bulb is becoming positive, negative? 100 times. In US, it is becoming how many times? 120 times. Is this concept understood? Ideally, see, voltage, neutral. Voltage, neutral, neutral, voltage, voltage, neutral, voltage, neutral, voltage, neutral. It's happening this. So you should say, sir, the bulb should also fluctuate. But what is the speed? 100 times in 1 second. We are such fools that you read about persistence of vision in grade 8. If anything is shown more than 1/16th of a speed, it appears continuous to us. Time-lapse paintings that we do. If you increase the speed more than 1/16, it appears to be a whole story moving. 1/16th, this is what? 1/50th. We are super fool in this case. You actually cannot even make out when the bulb is switching on, when the bulb is switching off. Have you understood this? Okay. Now my question is, sir, so far you were saying that the EMF that we have, or the voltage, okay, many books will write this as V at T. Whatever is your wish, you can write. I can write this as E naught sine omega t, and I can write this as V naught sine omega t. In both the cases, children, this stands for the peak value, right? Let's talk about the voltage. Sir, in both the cases, you are writing it as this is a function of sine. That means this signal should go up, come down, again go up, come down. It should go like this. How are you giving me a steady value of 240? What is this value? How did you give me a steady value of 240? Obviously, we have an alternating signal. How can the voltage be 240? Similarly, if I say that my fan is, I have an air conditioner which is pulling 9 ampere right now, and if you actually put a AC, what will you put? A AC emitter, right? Sir, why are you using the word AC emitter? AC emitter is different from DC emitter. So in an AC emitter, the reading will come how much better? 9 ampere. But sir, the current is always given by the equation I at any time t should be equal to I naught sine omega t. Why is this not fluctuating? And if I put a AC voltmeter, it is reading 240. That means some locha is out there. Okay, they are trying to show you some value which is a representative value. You just try and think. If I tell you that the price of potato fluctuates every day in the market, right? And the value is 30 rupees, 50 paisa, 40 paisa, 60 paisa, 70 paisa, 80 paisa, 90 paisa. Does that make any sense to you? You will say, okay, tell me a ballpark figure, 32 rupees. That's a representative price of the potato that you are buying, and it helps you rather than telling you, hey, today you're going to market, today it is 30 rupees, 60 paisa, take 60 paisa with you. Doesn't help you. So these are some representative values that we are getting. What are these representative values? We should understand. In the field of alternating current and alternating voltage, we have two values. One is known as average value. Average value. Another is known as RMS value. RMS and average. This is very important for your syllabus. RMS. So there we have some formulas, but those formulas, how they came, we will see. That is where we will just be a little bit cooperative with him. He might find it boring. But now, question comes, sir, the average value is always given by, in your book, you will see it is 2 I naught by pi, and this is given by I naught by root 2. RMS value. Don't get used to this. My question is, I'll clear some myths. Whenever they say, what is the average value of an alternating current? Sir, the average value of an alternating current is 2 I naught by pi. Your book will write that. Not exactly. Average value of an alternating current with a sinusoidal signal only has this value. If my alternating current was something like I equal to I naught 3 I square. Are you understanding? 3t square. That will not have this value. And in our syllabus, what type of alternating current will we study? Sinusoidal alternating current, because that's a very clean signal that you get. And that clean signal can be operated only by distribution companies, because it takes a lot of effort and a lot of engineering to get that sine curve. For example, suppose you have gone to any of these marriage parties which are hosted in the open air marriage parties, right? Which are which you have a club, or you have a, in the month of December, there's an open garden party going on. Now you will see that a generator has been kept as a backup, and that generator will be running with get when it comes out. So keep it at a far off distance. That generator is never going to give you I equal to I naught sine omega, sorry, E equal to E naught sine omega t. This is very tough. Now you should ask a question, sir, when our power failure happens, does our generator give it? May not be exactly. But right now we are on main powers, the distribution board. Right now, if you connect an oscilloscope, you will exactly see the sine curve. What happens when the DG generator switches on? Their DG generator will also switch on, but they will not be able to maintain this 50 hertz. 50 hertz maintaining is very, very tough. That's why if you come to my house any day, how do you get to know? Right now we are running on DG or we are running on main power. So in my house, there is a frequency meter fitted. So if the frequency meter reads 50 or 49.8, that means I'm on cheaper electricity. And if the frequency meter reads something like 51 or 51.5, that means the diesel generator is on. Everything is costly. Be it, if you want to bake a cake, don't bake it right now. If you want to have a cycle wash on your clothes, don't do it right now, because the price of the electricity is very, very costly. Have you understood? So the idea behind it is, getting a sine signal is a very costly affair. That's what they say. If you see the ads, it comes new luminous sine wave inverter. Means that particular inverter will be giving you an exact sine wave. That inverter will be a little bit more costly than other inverters. They proclaim that their output is exactly sine, not because I am using luminous, because their power quality is very good. But if you actually take a Sony Bravia TV and you connect it to those roadside vegetable vendor AC generators are there, which goes on, in 3 to 4 days your television will conk off, because you are getting 240 volts. If you light a bulb, the bulb will light, but the quality of the signal is not good. At that time, what we need is called a spike arrestor or a voltage stabilizer who will stabilize and clean your signal. A UPS gives you a very good power. Therefore, using a UPS for televisions is very, very safe. Okay, so we will be learning about something called average value and RMS value. I'll come to RMS value later. Let's first understand what is average value. So let's take our signal. Our signal is actually a sine function, right? And the signal is a sine function. Let's dive a little bit into mathematics. Let's say we have a function. We have a function which is, say, f of t. Some function which is f of t. Right now your function is what? Sine omega t, E naught sine omega t. You have a time varying function. Clear? In this time varying function, somebody tells you what is the average value of this function, right? What is the average value of this function? So let's again look at our, whatever it is, current or voltage. So we'll go by current. So our current function is going in this manner. This is 0, this is pi, and this is 2 pi, right? This signal is I at t equal to I naught sine omega t. And I tell you, over one cycle, my bacha, can you tell me what is the average value of this function? You will say, what a question are you asking? At half of this time span, it is on positive, and at half it is negative. So the average value should be 0. So whenever you have a sinusoidal function, you generally, or a cost function, you generally do not calculate average over a cycle. So we will be calculating average over what, beta? Half cycle. You will be calculating your average over half cycle. Is this concept clear or not? You don't calculate it over a cycle, because calculating it over a cycle will give you a 0. Our job is now to calculate the, our job is now to calculate the average value of this function over half cycle. We keep it aside and we go to mathematics. We say we have a function f of t. Sir, how to calculate? In your book, they will just say the value. How did this value come? We need to calculate average of this function. How do you calculate? Average means, what does average mean? What is the function's behavior from time blah blah to tla tla, some time gap. Over this, we have to find out the average, right? So let's say the way we find the average value of any function, we will integrate this function from say some 0 to t. 0 to t is a time interval from 0 to some t, and we will divide it again by an integral 0 to t dt. Please understand, t is the time at any instant. This t is, I am trying to find the average from 4 o'clock to 5 o'clock. 4 o'clock is 0 time and 5 o'clock means 1 hour. Have you understood? Now you will say, sir, how did you get this formula? Very easy. What does f of t mean? F of t means area under the curve. What is area under this integral means? What? Area under any curve. What is area in terms of motion? Displacement divided by dt. Integral is what? T. Displacement over time is what? Average velocity. This is average velocity. So this will give you average. Any function's average is calculated by this formula. Clear? So suppose you want to find out average value of a function f of t from 0 to t. The formula is given by integral 0 to t f of t dt divided by integral 0 to t dt. This is the formula. And we will now use the same formula to find out the average value of our current. What is the average value of current? 2 I naught by pi. We have to achieve this. Ready? So let's see. So let's say now our time average value of this function IFT is evaluated over half cycle. This is what you have to first thing remember. It's evaluated over half cycle. Agreed? So in that half cycle, and let's say time for half cycle spans from 0 to t. Okay? Understood? Okay. So my I average should be equal to integral 0 to t I at t dt divided by integral 0 to t dt as per my mathematics formula, right? The function. And this can be further written as integral 0 to t I naught sine omega t dt divided by integral 0 to t dt. Do you agree or not? Right? Now we have to do some changeovers. Look, these values of t, we have to come to realistic value. Now, in one cycle, omega is known as what, beta? Angular frequency. What is the value of omega? Omega is given by 2 pi f. This is, absorb it, huh? This is for one cycle. So for half cycle, my omega will be pi f. Agreed? So I would write half cycle means this entire thing is happening on half cycle. So my omega for this calculation will be given by pi divided by t, because f is 1 upon t. That means my t is nothing but pi by omega. Do you agree? T is equal to pi by omega. Clear? What did I do? For one cycle 2 pi f, for half cycle pi f. Right? That means my I average now can be written as integral of 0 to pi by omega I naught sine omega t dt divided by integral 0 to pi by omega dt. बच्चा देखो तो, have you understood this part? Hope it is not getting over your dimag, huh? Okay, na? Even if it is not okay, do say okay. That gives me a lot of confidence. Making it smaller now, since you have understood. Okay. For our simplicity, So you must be thinking, what big integrals, this man is eating my head. So our simplicity will solve numerator and denominator separately. Agreed? So let's first solve. I think everyone will like to solve the denominator first. The denominator. What is the denominator? 0 to pi by omega dt. This is equal to dt's integration will always be t beta, right? And what are my limits? 0 to pi by omega. That means my value is equal to how much? Pi by omega minus 0, which is equal to pi by omega. Any doubt? No doubt. Very good. So let's make the denominator also small now. Okay. Come. Let's now try to do the numerator. Numerator. A numerator. What is my numerator? My numerator is, right? My numerator, can I take the I naught outside because I am handling what beta? I am handling I naught is a constant, peak value, right? Peak value or maximum value, whatever we call it. 0 to pi by omega sine omega t dt. Sine omega t dt. Now this is for our friend Arjun. Arjun, just see, right? D by dx of cos x gives me negative sine x. Therefore, integral of negative sine x dx should give me cos x, or integral of sine x dx should give me negative cos x. Have you understood this? And if my sine x would had a sine mx, sorry, if my sine x would had a sine mx, then it would be cos x by m. If this is a mx, it will be cos x by m. We know that. In differentiation, it comes out. So what is the integration of this? I would say that my numerator's integration will give me I naught. Then sine omega t means a negative comes out here, right? So I'm taking I naught negative cos omega t divided by omega, and I have my limit set at 0 to pi by omega. Clear or not? Okay? Can I bring my I naught by omega outside? I brought my I naught by omega outside, being a constant. I still retain the negative inside, and now this becomes cos omega t with 0 to pi by omega as my limits, and this is closed. Okay, bacha? We again make this smaller a little bit, not yet done. Make it a little bit smaller, and I'm keeping it here. So proceeding further, my numerator, I'm still calculating my numerator. My numerator is now I naught by omega, second bracket open, negative. Now just see, upper limit minus lower limit. What is the upper limit? Cos omega. Instead of t, I am writing pi by omega. Bacha, clear? Instead of t. This minus cos, instead of t, I will write 0, which is nothing but cos 0. Minus cos omega into 0. Pretty fine? Cos omega into 0. Upper limit minus lower limit. Clear though? You suddenly gave a vague face, Zoe, so I got a little bit worried. Minus. Okay. This becomes what? Omega cancels omega, cos pi minus cos 0. You understood? This is I naught by omega minus, acha, sin pi. Sin pi is 0, cos pi is always, cos 0 is 0, cos pi is minus 1. Minus 1. Minus 1, minus 1. Cos 0 is 1. Cos 0 is 1. Cos pi is minus 1. So this is minus 2. So ultimately this value becomes how much? I naught by omega multiplied by minus 1 is minus 2. Minus 2 into 2 is 2. So this is equal to 2 I naught by omega. Is this clear? right? This was what beta? This was numerator. Now it is our time to do our substitutions. So from the numerator we write 2I naught by omega divided by, what is the denominator? Pi by omega. So this is 2I naught by omega into omega by pi. This cancels. 2I naught by pi. I average. I average. This is a very important 1 mark numericals that may come. They might give you what is the peak value. They will ask you to calculate the average value. What are the things we have kept in consideration out here? Average value mathematically for any function is 0 to t f of t dt divided by integral 0 to t dt, right? But if we take an alternating signal and we try to find out the what is known as average value, the alternating signal has got a one crest and one trough. They cancel each other. So finding an average value over a cycle is a foolish act. So what do? We find the average value always over half cycle. So when we find over half cycle, the only massaging that we do is to the angular frequency. The angular frequency is 2 pi f, it becomes pi f. Arjun beta, nobody will ask you to do all these things. But this thing we have understood how this thing comes. So you need to have this formula right now. Okay. And if you take a calculator, there will be a fixed value. So let's take the value. So it is 2 divided by how much? Pi. 2 divided by pi. So this value is 0.636. So many people take it as 0.637. So the I average of a sinusoidal alternating current is given by how much? 0.637 times the peak value, where this is known as my peak value. Peak value. Clear? Now the most interesting thing. Now the most interesting thing. Alternating current is very interesting chapter. R. Now see, how to define average current. Have you seen the average current has come a steady value? This is not alternating. This is not alternating. So what is this? What is the average value? The average value of an alternating signal over half a cycle is equivalent to a steady current of the value 0.637 times the peak value of the alternating current. That means in a half cycle is some time. This is some time beta. What is current? Rate of flow of charge. If you have an alternating current in this half cycle, it will be pushing some charges. That quantity of charge is same as a direct current of 0.637 times IO that would have pushed over the same time frame. I will explain, but first you have to understand. Once again, this is an alternating current. Beta, in an alternating current, every time I ask you what is the current value, you will try to ask me at what time, because the current is a function of time. So this becomes very irritating. So you can tell me at 36 seconds what was the current value. We can't go like that. So we need something like average. In a cricket, we say what is the average scoring rate. So you found an average value, but when you find an average value, you have killed something. Is there any periodic function with it? No, you have killed the periodic function. That means you have got a stagnant value. At a stagnant value, is this not a direct current? This is a direct current. It can be plus, it can be minus, but the magnitude is fixed because I naught is fixed. So 0.637 I naught is fixed for you. And this is representing the average over half cycle. It's a representative data of the average of half cycle. Now let's forget this and think about this. Whether it is an alternating current or direct current, over half the cycle, it must be pushing some charges. What is current? Rate of flow of charge. So in this time, some charges must have passed through the conductor when this alternating current was connected to me. I am a conductor. You connected an alternating current to me. So over this half cycle, some charges have gone through me. Those charges will be exactly equivalent if instead of the alternating current, you would have connected a direct current to me, which is 0.637 I naught. And how would you got the direct current from a DC generator? A cell, a battery? These two are equivalent now. So we say, first understand, then we'll again write the average current. No, don't write, first understand the average current, the average value of a sinusoidal current over half cycle pushes the same amount of charges over half cycle, over the time duration of the half cycle, that a steady current of magnitude 0.637 times the peak value of that current would have pushed. Because we cannot work with a fluctuating something. Even if a child keeps on fluctuating in front of me, I'll let him sit at one place first. You have made him sit at one place. In that sense, it has become now a direct current. So once again, let's try to make it better in English. The average value of an alternating current, let's write the average value of an alternating current, the average value of an alternating current given by the function I at t is equal to I naught sine omega t. The average value of an alternating current given by the function I at t equal to I naught sine omega t, and you can add one more adjective, the average value of a sinusoidal alternating current. You put the word sinusoidal, that is important, because only if it is sinusoidal then you get this value, otherwise you will not get this value, the integration will be different. The average value of a sinusoidal alternating current given by the equation or given by the function I at t equal to I0 sine omega t, right, pushes a quantity of charge, pushes not a quantity, pushes the same quantity of charge, pushes the same quantity of charge over a half cycle, that would be pushed by a unidirectional current of magnitude 0.637 into IO, 0.637 IO, for the same duration, period, and write in bracket where IO is the peak value of the alternating sinusoidal EMF, where IO is the peak value of the alternating sinusoidal EMF. Sinusoidal EMF. Have you understood this? Now you just read. Average value of such type of a signal. Look at me, it will be easy. Average value of such type of a signal, right, pushes the same amount of charge over half a cycle as the amount of charge that would have been pushed by this current for the same duration, right? एक डीसी करंट आपको जितना चार्ज पुश करता, ये ऑल्टरनेटिंग करंट उतना ही चार्ज हाफ साइकिल ड्यूरेशन में पुश कर रहा है. Clear? Job is still not done. into so if I come back here now, if I come back here, so I said the average value is this, and similarly the average, this is the value of I average. So what will be the value of V average? 2V0 divided by pi, same value, 2V0 divided by pi. Why I mentioned the word sinusoidal? Because if it is not sinusoidal, you will not get this value, because then the integration will be different. Suppose my current is logarithmic series, uska integration thodi ye aayega. I got it. Now question still arises, sir, when you put your multimeter here, this is measuring one fixed value, steady value. Was this the average value? No, this is not the average value. Then sir, where do we use average value? We will see where it we use. Then what is this value that we are using? This value is known as the RMS value. Achha, what is RMS value? Let's try and understand before we see that derivation. Maybe we may not be able to do that derivation today. RMS is very interesting statistical approach. You try to do an average, and you try to do the average over half cycle, but now I need the data for full cycle. But sir, for full cycle, if you do average, you will land up in 0. So what I do, in standard deviation, we use this. This is known as root mean square. Root mean square. Suppose this data, this is a data of +1, then this is a data of -1. If you square up, then this -1 will also become +1. So whenever data is fluctuating, I am squaring all those data. Right? Those datas, when I have squared up, I will be taking an average of them, mean. And you squared it, right? So you will root it again. RMS is called a better approach of mean. In standard deviation, we use it because in standard deviation, you get negative data also, variance, which is now taken off from CBSE's 11-12 syllabus. I think in grade 10, 11, you had that variance, mathematics. Yeah, variance was there, you have forgotten. Sigma, standard deviation and variance, sigma square. Mean deviation was there. So in mean deviation, what did you do? You actually, when you used to do mean of deviation, then you used to square it up. Why did you square it up? Because you converted all negatives to positive. So since you square it up, then you take the mean, then you take the root. This is also a way of getting an average, much more stricter way. And we're trying to find the average over a cycle. That's why we have to go by this approach. So let's see. We want to now find out the value of, say, IRMS. We won't do the integration today. We want to find out what is IRMS, or we want to find out what is VRMS. So before going further, understand that when you put in a plug point any voltmeter, this is separate from grade 10, AC voltmeter, this fellow is neither reading your peak value, neither reading your average value. All measurement devices read something which is known as RMS value. My child got a shock of 220 volt. How do you say that? Voltage was from 0 to peak to down. So the average shock that the child must have got is how much? 220. That is the RMS value. समझ में आ रहा है? तो RMS कैसे calculate करेंगे? तो कहता है you need to square up. So we will do what? We will square our function. Then you need to find its mean. So we will be trying to do its average, 0 to t dt over again a 0 to t dt. And then we have to do, appears very tough, very easy. Even give a try at home. But there is a change here. Omega is equal to 2 pi f. This time my study is over one cycle. So you will not massage omega. Got it? So my omega can be now written as what? 2 pi by t. So t becomes omega by 2 pi. Earlier t becomes 2 pi by omega. In the previous integration, we used pi by omega. This time we will use 2 pi by omega. Why? Because sir, you are doing RMS over one cycle. Over one cycle. One cycle. This is passionate topic for me. I enjoy this. One cycle. आज notes सोचने चाहिए. Over one cycle. Did you get it? So over one cycle, when we do it, we'll do this integration we'll do in our next class. Don't worry about it. The only problem what will come in this whole thing, just try. Denominator will still be easy. We will not process the root first. Denominator will be easy. In numerator, my bacha, the problem that you will get is your numerator will be I square sine square omega t dt. This sort of an integral you will be getting 0 to 2 pi by omega. Do you agree or not? I square being a constant will come out. You have to integrate this. We'll be compassionate with him. Sine square theta is equal to 1 minus cos square theta. Right? Cos 2 theta is equal to 2 cos square theta minus 1. That means cos 2 theta plus 1 divided by 2 is cos square theta. Do you agree? That means 1 minus 1 plus cos 2 theta divided by 2. If you take the whole thing, this becomes 2. 2 minus 1 is 1. 1 plus cos 2 theta divided by 2. 2 ones are 2. 2 minus 1 is 1. 1 plus cos 2 theta divided by 2. Yeah. Sine square theta is, oh, this is minus 1 minus, sorry. That's what I was thinking. Why did it change? So this will become 1 minus cos 2 theta divided by 2. This is sine square theta. That means when you will do your integration, you have to make one small substitution. And what will be your substitution? You will land up with sine square omega t. So you will write sine square omega t as 1 minus cos 2 omega t divided by 2. This part will be integrated very easily. This part also. That we will do in our next class, and we will arrive at the RMS value. Have you understood? Initially, you will get a lot of calculation that the RMS value is so and so. Calculate average and peak value. All we can do. Okay? Hope it was not going beyond your head. So whenever you get an alternating signal cannot give you, tell me the position of my finger. You don't know. You don't know. So you have to give a resonant. Anything which alternates, benzene structure, that circle, you have to give a, I need to study you somewhere. Kahin to khara ho jao. So that's an average value, or we use something which is known as an RMS value. And there's something more called peak value. There's a peak value. I naught. So we will get the value of peak value. So remember, average value is given by 2 I naught by pi. People remember it like that, but the question is, it's 2 I naught by pi as long as it is a sinusoid.